Before we jump into this last little bit, I want to go back to where we were doing these with a certain number of rectangles. So let's say we just have this function. I'll just do here, I don't know, from 0 to 1, let's say. And we were trying to find the area in between that, okay? So we had talked about how we can use the left endpoints, okay? Maybe look something like this to find it. And remember, that was an area that was too small because it was inscribed. And then we could also do this with right endpoints. And so we make our rectangles that look like this. And remember, that area was too big. We called that the upper bound because those were circumscribed. Okay, so they overhang. So since we have one that's too big and one that's too small, boy, it'd be nice if we had a happy medium. And we can do that. Let me see if I can draw this thing again. Okay, so we have this function. So rather than using a left endpoint or a right endpoint, we could use like the midpoint of a rectangle. Looks like that. So there'd be a little overhang and a little underhang on all of these. Okay, pretend all of those rectangles are the same width, please. So that's what this next part says. It is the midpoint rule. So rather than using the left or the right and having it too big or too small, the midpoint's just going to give us a better estimate. Okay, so if we use the midpoint, then CI is this, xi plus xi minus 1 over 2. And then the area is this formula, okay? So it's still taking a sum of all of our rectangles. This is the width of the rectangle, and then that's the height, plugging into the function. Now, we use the midpoint rule not when we're doing the limit. We don't want infinite number. Okay, this is for when it's a defined number, so 4 rectangles or 8 rectangles or something like that. So let me show you what this is going to look like for number 8 here. We want to use the midpoint rule with n equals 4. So that's what I was just saying, that this is a defined number of rectangles. To approximate the area of the region of the graph of sine x, the x-axis, and from 0 to pi. So we know that sine goes through the origin. Okay, it goes up and back, and then it goes down and back. So over here, this is 2 pi, but remember, we only want to go to pi. Okay, so we actually don't need this lower part. Okay, so this is the area that we're trying to find, okay, under that curve. Now, we are going to split this up into 4 rectangles. Okay, so I might need to make this bigger. So this is pi over 4, pi over 2, and 3 pi over 4. And now when we're drawing these rectangles, rather than doing a corner, we want to hit in the midpoint. So see, we have a little bit overhang and under. We want the midpoint here, over and under, the midpoint here, so it's over and under, and the midpoint here. Okay, that's not a beautiful picture, but you get the idea. Okay, so we are going to use that formula. Okay, this thing right here. So the area is going to be the sum from 1. And now they told us what n was. So it's from 1 to 4 of f of ci. That's ci right there, delta x. Okay, so we need to figure out what ci and delta x are. So let's start with delta x. That's the easy one. Remember, delta x is b minus a over n. In this case, b and a are pi and 0. And again, n is 4. So the width of all of those rectangles is pi over 4. And we could have seen that from our graph. So we know that. All right, so we still have to talk about CI. We'll get to that in just a second. Okay, so we can actually do these individually, no big deal. So C1, okay, remember, we're going to take these and plug them in one at a time. So we're doing f of 1 when we plug it in C1. times pi over 4 plus f of C2 times pi over 4 plus f of C3 times pi over 4 plus f of C4 times pi over 4. So we need to figure out what C1 and C2 are and all of that. Okay, so C1 is x1 plus x0 over 2. Okay, so here is x0 and here is x1. So this is 0 plus pi over 4 divided by 2, which is going to be pi over 8. Okay, so what that's telling us is pi over 8 is the midpoint of that rectangle. So we want to do sine of pi over 8 times pi over 4. And then we want C2. C2 is going to be x2 plus x1 over 2. So that will be pi over 2 plus pi over 4 divided by 2. And that's going to be 3 pi over 8. Okay, so that's telling us that 3 pi over 8 is the midpoint of this rectangle. So we want to do sine of 3 pi over 8 times pi over 4. Now, you may be able to figure out C3 without doing the actual formula. It's going to be the midpoint of this. So in between pi over 2 and 3 pi over 4 is going to be 5 pi over 8. So we have sine 5 pi over 8 times pi over 4. And then we have one more. We need the midpoint here between 3 pi over 4 and pi, which is going to be 7 pi over 8. So we have sine 7 pi over 8 times pi over 4. Okay, so those we don't have exact values for. We're just going to do this all in the calculator. So you put that all in your calculator. One thing you could do to make it easier to put in the calculator is notice these all have a pi over 4. So you could factor that out and do sine of pi over 8 plus sine of 3 pi over 8 plus sine of 5 pi over 8 plus sine of 7 pi over 8. Put that all into your calculator and then multiply the answer by pi over 4. But either way, you're going to get a decimal answer. Make sure you're in radian mode. 2.052. So we approximated the area under this part of the sine curve at 2.052 using midpoints.